In this lesson, we're going to be dividing radicals and we're going to be using the quotient rule, and our focus will be on square roots. Now, remember in previous lessons when we used the quotient rule, we used it with this respect. So we had the square root of a divided by b. And so whenever you're taking the square root of a quotient, then what we did in those lessons was we wrote it as the quotient of the square root of the numerator divided by the quotient, divided by the square root of the denominator. All right, and so that's how we used it in previous lessons. Now, again, we were assuming that first of all, any variables in the problem represented positive numbers, and we also stated that that a must be non-negative and must be a real number, and b must be a real number, and b cannot be 0, because if b was 0, then the denominator would be 0, and this fraction would be undefined. But basically, this was the idea. So you're taking the square root of a fraction, and so you can write it as the fraction of the square root of the numerator divided by the square root of the denominator. All right. Now, what we're going to do in this lesson, though, the way it's going to look like this. So we're going to kind of go backwards. So given the square root of a numerator divided by the square root of the denominator, so given the quotient of a square root, and it doesn't have to be square root. The lesson here is on square roots, but it could be cube roots, fourth roots, fifth roots, any kind of root would still apply here. So, so the square root of a divided by the square root of b, I can write this as one square root, and it'll be the square root of a divided by b. All right, so it's very similar to our previous lesson when we talked about the product rule. So I just want to remind you about that. So in our previous lesson, remember we had first of all talked about the product rule from a while back. So where we had the square root of a times b was the product of the square root of each factor. Then in this lesson, which is similar to what we're going to talk about today, we had this where we could go the other way as well. So the square root of a times the square root of b, I can write as one square root by just multiplying the radicands. The same thing here. So if I have the square root of a divided by the square root of b, I can write it as one square root by just dividing, just by making the radicands, the radicand of the new square root, the radicand of the numerator, and the radicand of the denominator. All right, and so it's not a difficult process. It's a very simple thing to do. All right, so let's look at an example. So it's just going to say something like divide or simplify. Now remember, you always want to simplify whenever possible. So divide and simplify. Okay, so this way it's going to look. So number one, I have the square root of 14 divided by the square root of 2. All right, well, notice that the first thing you always want to do is always see if you can use the quotient rule with this, and if quotient rule, when you use it, if it'll help the situation in terms of simplifying. So notice I have a square root of the numerator and I have a square root of the denominator. So according to the quotient rule, I can write this as one square root. I can write this as the square root of 14 divided by 2. And notice that I can simplify 14 divided by 2. That's 7. So go further. So far we're on the right track. And then notice I can't simplify the square root of 7 any further because the only perfect square that goes into 7 is 1. And there's your answer. That's all you do. Okay, so you divided these two square roots. You wrote it as one square root using the quotient rule, and then it turned out that you can simplify the radicand into one number. Okay, so you went from a fraction to a whole number in this case. All right, number two, you have the square root of 15 divided by the square root of 3. All right, so let's use the quotient rule and see if that's going to help us in terms of simplifying. So I get the square root of 15 divided by 3, and notice 15 divided by 3, I can make it simpler. 15 divided by 3 is 5, so therefore, and I can't simplify this any further, so there's your answer. All right. Number 3, and remember, you can't simplify that any further because the only perfect square, and we're already dealing with square roots, so that's why we talk about perfect squares. The only perfect square that goes into 5 is 1. Okay, let's look at number 3. So number 3, I have the square root of 90 divided by the square root of 2. All right, and so notice the quotient rule is going to help here because 90 is divisible by 2. So I'm going to get the square root of 90 divided by 2, and that's going to equal the square root of 45. Now the question is, can I simplify the square root of 45? Yeah, you can, because what perfect square goes into 45? And let's use the largest, and that will be 9, right? So that'll be the square root of 9 times 5, which using the product rule now, so I'm going to use the product rule, I'm going to get the square root of 9 times the square root of 5, and then the square root of 9 is 3, so I get 3 square root of 5. Okay? All right, now just wanted to say something. See how when we looked at numbers 1, 2, and 3, the original problems, I went directly to the quotient rule, and it seemed to help at that point. Okay, there will be a situation. Let me just go ahead and write this as example in the next lesson where I have something like the square root of 3 divided by the square root of 2, and then if you go directly to the quotient rule, 3 divided by 2, I can't write in a better way. I can't write as one number like I did here, like I did with these. So we are going to use a different approach. We will use a different approach in the next lesson. Okay? So that's where we're going to talk about something else. So sometimes when you get a problem like this and you notice, hey, going straight to the quotient rule is not going to help. So I have to use a different approach. So that's the situation here. Okay, you see 3 is not divisible by 2. So we have to try something different. And we're going to talk about that in the next lesson. All right, so number 4, we have the square root of 100 divided by the square root of 5. So notice 100 is divisible by 5, right? So let's go ahead and use the quotient rule. So the quotient rule, I get 100 divided by 5. And so 100 divided by 5 is 20, so I get the square root of 20. And now let's see if I can simplify the square root of 20. And I can, because the 4 is a perfect square, and it's the largest one that goes into 20. So I can write this as the square root of 4 times 5. Using the product rule, I get the square root of 4 times the square root of 5. And so the square root of 4 is 2, so the answer is 2 square root of 5. Okay? All right, let's do number 5. So see, it's not that bad. So let's look at number 5. So number 5, let's say we had this in number 5. Okay, we have the square root of 125x cubed divided by the square root of 5x. All right. Now, you know that for the most part, you know that you're going to use a quotient rule here because 125 is divisible by 5. And then x cubed, I can divide that by x. Because there are 3 factors of x up here. There's only 1 down there. So there's more up here than there is down there. Okay? So the quotient rule is going to help us make things a lot easier. So this is going to be the square root of 125x cubed divided by 5x. All right, and so if you remember, I'm going to go to the side right here. I'm going to rewrite the radicand, and then I'm going to remind you about something you had in the previous topic where you simplified rational expressions. So you said 5 into 5 is 1, and then 5 into 125. If you can't figure it out real quick, then just use your calculator. So you say 125 divided by 5, and you're going to get 25, right? So that's 25. Now remember how we dealt with the x cubed. I have 3 factors of x up here, 1 factor of x up here. So I can divide this one by one of those. So that's going to be a factor 1, and I'm left with 2 factors of x. And so what I found is this. So what I found is that this right here, which is this, simplifies to 25x squared. So that's going to be what I'm going to have in my radicand, 25x squared. Okay? And now, you see how simple it becomes? So you are going to have to use something from a previous topic where we talked about rational expressions. Okay? So we simplified rational expressions. Now I'm going to use the product rule here. So when I use a product rule, I get the square root of 25 times the square root of x squared. And the square root of 25 is 5. And the square root of x squared is just x. And so there's the answer. So remember what this means. And we talked about this in previous lessons before. So what times itself is x squared. So whenever you're taking the square root of some variable raised to a power, if that exponent is even, that's the easy kind. So 2 divided by the index 2 is 1, so that's why that's just x to the first. So x times x times x, remember, is x squared, which is what you wanted. Okay? So there's your answer. Number 6, we have the square root of 54 x to the 5th power divided by the square root of 2x. All right? So square root of 54 divided by x to the 5th divided by 2x. And I know that using the quotient rule is going to help here because 54 is divisible by 2, and there are factors of x in the numerator, factors of x in the denominator, and there's more in the numerator than there is in the denominator. So let's go directly to the quotient rule. So according to the quotient rule, I can write this as 1 radicand, 54 x to the 5th divided by 2x. Now, for some of you, may need to go off to the side and kind of work with that rational expression that's the radicand. So I get 54 x to the 5th divided by 2x. And then let's simplify. 2 goes into 2 one time. 2 goes into 54 27 times. There are 5 factors of x here, 1 here. So I can divide these 5 by one of these. So that'll be a factor 1. I'm left with 4 up here. And so this simplifies to 27 x to the 4th. So that's going to be this now. So it'll be square root of 27 x to the 4th. Okay? All right, now using product rule, because we got to simplify this, using a product rule, I can write this as the square root of 27 times the square root of x to the 4th. Okay? And so what perfect square goes into 27? Because I can simplify this, that's going to be 9. So it'll be the square root of 9 times 3. And this right here, since the exponent is even, that's going to be easy. I can simplify this. I can simplify this now. What times itself twice is x to the 4th? X squared. And then let's just rewrite this a little bit further. So it'll be the square root of 9, square root of 3 times x squared. And the square root of 9 is 3. So I get 3 square root of 3 x squared. Or if you want to rewrite it, you want to put the radical at the end, you'd say 3 x squared, square root of 3. Does not matter. Okay, so it's number 6. So remember in 7 and 6, you ended up having rational expressions that you had to simplify. And then so this simplifies to this, and then you can use a product rule and simplify this radical further. Same thing here. This rational expression, the radicand, which is a rational expression, can be simplified to this, and then that simplifies to this right here. Okay? All right, let's look at number 7. So number 7, we have this problem. So let's say we had the square root of 96 x to the 7th y cubed divided by the square root of 3 x squared y. All right, so let's say we had that. Okay, so before you go any further, I know I can use the quotient rule, but let's just see if 96 is divisible by 3 first of all. So 96 divided by 3, I get 32. So it is. And then remember, you can always tell if a number is divisible by 3 if you don't have access to a calculator. I mean, you could do the long division, right? But just add the digits. So 9 plus 6 is 15, and 15 is divisible by 3. So that means 96 will be divisible by 3. So that's just a divisibility test that you can use. All right, so let's just go ahead and write this as one radical using a quotient rule. So according to the quotient rule, I'm going to get 96 x to the 7th y to the 3rd divided by 3 x squared y. All right, and so let's go ahead off to the side and kind of work with that rational expression. So try not to simplify this within here because it gets too messy. So just go off to the side. So I have 96 x to the 7th y cubed divided by 3 x squared y. All right. So I know that 3 goes into 3 one time, and 3 will go into 96 32 times. I have 7 factors of x here. I have 2 here, so all of these will divide into 2 of these, so you're left with 5. And then this factor y divided by itself is 1, and then y cubed divided by y would be, you'd have 2 left, 2 factors of x left. And so therefore, remember, look at the numerator. The numerator is 1, right? I'm sorry, the denominator. The denominator is 1. 1 times 1 times 1 is 1. So all you're left with is the numerator. So it'll be 32 x to the 5th y squared. Okay? So I get this now. I get the square root of 32 x to the 5th y squared. All right, now let's simplify this. I can simplify this because notice, for one thing, I can simplify the variables because the exponent here is greater than or equal to the index. All right, and the same thing here. 2 is equal to 2, so I can simplify that. Okay, so using the product rule, I get the square root of 32 times the square root of x to the 5th times the square root of y squared. And then let's simplify the square root of 32. So 32 I can write as, using the largest perfect square, 16, I can write this as the square root of 16 times 2. X to the 5th, now remember the square root of x to the 5th, so remember this is odd, so remember how we did this. So, and remember this is square root. And so since this is odd, we can look for the largest whole number less than 5 that's divisible by 2, and so that will be 4. So I can rewrite this as the square root of x to the 4th times x. And always make sure that this is this. So x to the 4th times x to the 1st is x to the 5th. Now since this is already even right here, I'm just going to go ahead and simplify it now. The square root of y squared. So what times itself twice is y squared? That's just y. So the square root of y squared is equal to y. All right. Now again, we're always assuming in our lessons that the variables represent positive numbers, so we don't have to worry about absolute value. So I don't need an absolute value here. Okay. Now here I get this. Now using the product rule, I'm going to get the square root of 16 times the square root of 2 times the square root of x to the 4th times the square root of x times y. Okay, so let's simplify what we can. So this is a 4. Square root of 16 is 4. I cannot simplify the square root of 2. The square root of x to the 4th, 4 is even. So what times itself twice is x to the 4th? X squared. I cannot simplify the square root of x times y. All right, now what I'm going to do is this. So I'm going to put the square roots on the end. So here's what we have. So remember, usually in our answers, we'll have the square root on the end. So I have 2 factors though, right? I have a factor of square root of 2, and then I have a factor of square root of x. So I'm going to put this first, then this, then this. I'm going to have 4. So remember, this is all products. So the order in which you multiply does not matter. So we have 4 times x squared times y times the square root of 2 times the square root of x. So all I did was just rearrange the factors. And now remember, you cannot leave it like this because you know that you can use the product rule again to write this as 1 square root. So you need to do that. So I get 4 x squared y times the square root of 2x. And there's your answer. Okay? So that was number 7. And I think that should help you with this part of our lesson. And that was the lesson where we were dividing radicals using a quotient rule, and we're dealing with square roots. And so that's it. That's what this lesson deals with.